Hello everyone, we are from Division A. Me, Rakshita Ganjewar, and my team, Dhanashri, Rucha, and Rutuja, are going to take you on a quick journey through one of the most essential yet invisible system that powers the internet every second. Our topic is how domain name system or DNS works and how its secure version DNSSEC keeps your online world safe. So let's dive in and understand how your browser instantly knows where to go the moment you type a website name. DNS is like internet's giant phone book or a contact list. Every time you type a website, say www.example.com, your computer doesn't understand names. It needs numbers called IP address. So DNS quickly looks up to the correct number for that website and sends you there in just a few milliseconds. This process happens billions of times a day around the world, allowing users to access websites smoothly. But here's the problem. When DNS was first created, the internet was small and trusted. So security wasn't a big concern. As the internet grew, attackers found way to trick it through DNS spoofing and cache poisoning. So even though DNS is incredibly fast, it take it also is a bit too trusting. It doesn't verify if the address it provides is genuine, which means hackers can pretend to be real website. And that's where exactly DNSSEC steps in.
This is DNSSEC, the Domain Name System Security Extensions. Think of it as a bodyguard for DNS, making sure every website address your computer looks up is authentic and safe. This envelope represents the DNS data your computer requests, the addresses it needs to reach websites. Just like a wax seal on an important document, this signature ensures your computer can trust the contents before using it. DNSSEC adds cryptographic signatures to DNS records, ensuring data integrity and authenticity. When DNS data is signed, your computer verifies it through a process called the chain of trust. Root zone holds the master key that starts the trust chain. Second, TLDs verify their keys using the root's records. Third, domains sign the data verified by their TLD. Fourth, your device checks all signatures to ensure authenticity. When you type a website, your request travels over the TCP/IP stack through the application layer to DNS servers. The resolver checks each signature from root to TLD to domain and then returns the correct IP to your browser.
The DNS is like a digital map of internet. It resolves the website into the IP addresses, helping your browser know where to go. But DNS has its own limitations. It doesn't verify the authenticity. It is like following a map without checking if the destination is real or not. You might reach up on a site you can't trust. And this is where the DNSSEC comes in. DNSSEC adds the digital signature to every DNS record. Each signature is an official seal, verifying that the information comes from the trusted source. Your computer checks each link step by step, from root servers to top level domains to website itself, creating a chain of trust. Without DNSSEC, the forged or the fake records can easily mislead millions of the users, directing them to phishing sites or malicious servers. But with the DNSSEC, every record is verified before it reaches you. It is like having a caller ID for the internet. You instantly know what site you are visiting is authentic. In short, DNS tells you where to go, but DNSSEC ensures you get there.
Net is protected by multiple layers of security: HTTPS, VPN, DNS or HTTPS, and DNSSEC. Each layer plays a unique role in keeping our online world safe. HTTPS secures the communication after you reach a website. It encrypts the data exchange between your browser and the site, preventing the tampering. VPN hides your agent identity by masking your IP address and routing your traffic through the private tunnels. It protects your privacy, but it cannot stop the fake DNS responses. DOH, DNS or HTTPS. It encrypts your DNS requests, keeping them private from the snoopers. But it doesn't verify the DNS data itself. Encryption is not the same as authentication. DOH hide your DNS queries, but it cannot confirm where they lead. To truly verify your destination, we need DNSSEC. DNSSEC is the final layer. It is the foundation of trust. It authenticates DNS data at the source using digital signatures, ensuring the information you receive hasn't been altered. DNSSEC verifies the destination so you reach the real website, not an attacker's copy. DNSSEC ensures internet trust by providing authenticity, integrity, and security for the DNS data.
When you type a website, your DNS query travels over the UDP protocol on port 53 to the DNS resolver. Using UDP, these packets move quickly without establishing a connection, carrying DNS data and digital signatures. Once records are verified, the resolver returns the trusted IP address to your browser. UDP makes DNSSEC fast and efficient while ensuring the authenticity of response.
Imagine logging into your bank's website. Without DNSSEC, a hacker could silently redirect you to a fake page that looks identical, stealing all your login credentials easily. But with the DNSSEC, every DNS response is digitally signed. Your browser verifies it before connecting, ensure the site is genuine. Today, major organizations like Google, Cloudflare, and ICANN have implemented DNSSEC, securing billions of the users worldwide. Governments and ISPs are gradually adopting to protect the critical infrastructure, from banking to healthcare and defense networks. DNS made the internet usable, while DNSSEC makes it trustworthy. Together, they ensure that when you click a link, you reach a real destination safely.